Okay, so this is part 3, or the last part of the lecture on redox or oxidation reduction reactions, and we're going to talk about predicting reactions. If you are given two reactants and you are asked, will this redox reaction happen? The basic rule is you can go from a stronger reducing agent to a weaker. You cannot go from a weaker reducing agent to a stronger. So there's a table that we look at to determine this. So you have to identify what is your oxidizing agent, which is being reduced. What is your reducing agent, which is being oxidized, right? And then you look at this table. The general rule, this is reducers, reducing agents, which means they're going to cause something to be reduced. So magnesium metal can cause cadmium ion to become cadmium. Magnesium can cause cadmium ion to be reduced, to gain electrons and become cadmium. It can go downhill. It cannot go uphill. Cadmium is too weak to cause magnesium ion to be reduced, to gain electrons and become magnesium. Magnesium is a stronger reducer. As a reactant, it can make cadmium as a product in a reaction with cadmium ion. Cadmium is weaker than magnesium as a reducing agent. It cannot make magnesium. So a weaker reducer cannot make a stronger reducer. This cannot be a product in the reaction of cadmium and magnesium ion. A weaker cannot make a stronger. So this is the general rule that we follow. And you refer to this table whenever you get the question, will something happen? And again, redox reactions happen or they don't. There are no bidirectional arrow like you have with acid base. So it's either going to go full extent or zero extent. Full extent is your stronger reducers and oxidizers will create weaker reducers and oxidizers, and these will not go backwards. So therefore, the reverse reaction cannot happen. So let's look at this. In this example, we have a reducer, magnesium, in a reaction with hydrogen ions, protons, right? This is an acid. So the magnesium metal can act on the hydrogen ions to cause the hydrogen gas. It can cause it to be reduced because it's stronger. So stronger reducer can make a weaker reducer. But hydrogen cannot make magnesium. So if you had a reaction of hydrogen plus magnesium ions and you were asked, can this reaction happen? You look at your table and you go, what's weaker and what's stronger? The weaker cannot make the stronger. And that's your determining factor. So if we look at these 4 examples, and when you get this on a test, the way you're going to get it, you won't have that table, but you will get the series. You're not going to be expected to, you're not going to let me type. Hang on. You'll get something like, you'll get, sodium is greater than aluminum is greater than zinc is greater than nickel, like that. See, so I'm going from top to bottom here. This is what you'll get on an exam. So you have to understand that this is a stronger reducing agent. This is a weaker reducing agent. I can go downhill. I cannot go uphill. Okay. So using that, let's look at these examples. Will the first reaction happen? Well, I always start with my metal because that's on the left-hand side. That's my reducing agent. These are the conjugate oxidizing agents. So I look at my reducing agents and I say, which is stronger? Well, where's zinc? Here's zinc. Where's sodium? Sodium's up here. Zinc will not react with sodium ion to cause sodium because zinc is a weaker reducing agent than sodium. That will not happen. The other way could happen, if this were written in reverse, sodium could react with zinc ion to make zinc metal, but the way it's written for A will not happen. Sodium ion and zinc metal are not going to make sodium metal. So the first one's no, but the second one, here's your hydrogen ion. This is acid with silver. So where's silver? Silver's down here. So silver, because you only look at the first part of the reaction, you look at the reactants only. Will silver react with hydrogen ion to form hydrogen element? No. It cannot go uphill. Silver is a weaker reducing agent than hydrogen. It cannot go up. That second reaction B will not happen. What about chromium and iron 3? There's chromium right here. Iron is right below it. Will chromium element react with the iron ion to make the element? Yes. It's going downhill. Chromium is a stronger reducing agent. It can make a weaker reducing agent. And of course, iron is your product. So you're stronger, in this case, is on the reaction side, the weaker or on the product side. Yes, that will happen. And if you look at iron, it's the same thing for the oxidizers, right? Flip this on its head. We look at our oxidizing agent. Iron plus will make chromium plus, 3 plus. The stronger will make the weaker. So regardless of whether you're looking at reducing agents or oxidizing agents, the stronger ones are on the left side, the weaker are on the right side of the product. But zinc ion and iron. Here's iron and here is zinc. So iron metal is trying to make zinc metal. No, it cannot go up. Iron is a weaker reducing agent than zinc, so D will not happen because iron cannot make zinc. It's a stronger reducing agent. So that's really how you determine, will a reaction happen? And so if you get a question like this that says this will not happen, you're told right up the front this will not happen, which is the weaker oxidizing agent? All right, first of all, if it will not happen, then the weaker isn't a reactant. It won't happen because they're trying to make stronger. So it's going to be one of these two. Which one of these is the oxidizing agent? The oxidizing agent is being reduced. What is reduced? Gain electrons reduction. So who's gaining electrons? Your zinc goes from a 2 plus to a 0. Your zinc is gaining electrons. If it's gaining electrons, it's reduced, is therefore the oxidizing agent. And your answer is A, zinc 2 plus. So it's a logic puzzle. Just take it step by step with the logic. Don't worry about this table. That's a little more complex than we're getting. The other, and this is the lab we would normally be doing right now, and I don't know if we'll be doing this in the fall or not, but I hope so. It's kind of fun. Another way we look, a table that we talk about these strengths of reducing agents is their reactions with water or with acid. So is it reaction with hydrogen in water or the hydrogen ion in acid? So the strongest reducing agents will react with cold water. There is no heat needed. You put metal potassium in a pan of water, which is normally what we do, and it blows up and it turns purple and it fizzes and it spits and then it's gone. It's really cool. So it will react with cold water instantly. These are strong reducers, reducing agents. If you have to add some heat to make this happen, so you have steam, you have very, very hot water. So what we've done here is we've added heat. That's the next level of strength of reducing agent. So what you do is you test each of these elements you start with water, And then you would, those that don't react with water, you try them with steam. Those that don't react with steam, you try them with acid. That's here. And so if they react with acid to give hydrogen gas, and that's partly how you know, you see hydrogen gas evolve. That's your product. Then it's in this area. And then we have this group that's a weaker reducing agent than the hydrogen element. And therefore they cannot make hydrogen. Remember, your weaker can't make stronger. And so they are all weaker. If they don't react with acid, they are all weaker than hydrogen. So this is called an activity series. And this is if you are, so if you're asked to give something in order and you say, well, you get A, B, and C, and you're told that A reacted with cold water and B reacted with acid and C reacted with hot water or steam, put them in order of activity. And you put the one that reacted with cold water stronger than the one with steam, than the one with acid. And if you get an example that says didn't react with anything, it goes below. And you use this to put a hierarchy, because you can also look at how quickly do they react. I mean, zinc might react with steam, but it might be kind of slow, whereas magnesium might be faster. So that's the other thing you look at. So this is called an activity series. And hopefully you'll be able to get to do this in the lab, where we rate the strength of a reducing agent depending on its behavior in water. So here's just a few more questions, practice questions. I just wanted to do the does a reaction happen or not in its own lecture piece. So which is the oxidizing agent and which gets reduced? Well, that's the same thing, isn't it? The oxidizing agent gets reduced. So what's getting reduced? Gain electrons reduction. Who's gaining electrons? Your hydrogen is, isn't it? It's going from a +1 to a 0 with the addition of an electron for each hydrogen. So hydrogen is going to be the answer to both, and that's B. Okay. This question is, which is acting as the oxidizing agent? The oxidizing agent, once again, gets reduced. Gain electron reduction. It's gaining electrons. Who's gaining electrons? The zinc goes from a 0 to a +2. It's losing 2 electrons. The platinum goes from a +2 to a solid, so that's 0. So the platinum is gaining 2 electrons. Therefore, it's being reduced. If it's being reduced, it is the oxidizing agent. And your answer is not the product, but it's the reactant side, platinum ion. So the answer is C. We're always going to be looking at the reactants. Okay, this question says, which species gets oxidized in the following reaction? Well, Leo says GER, lose electrons oxidation. So who loses electrons? Not silver, because silver goes from a +1 to a 0. It gains an electron. So zinc goes from a 0 to a +2. It loses 2 electrons. It now has more protons than electrons. But the species that's getting oxidized is zinc solid. So it's D. So it's always going to be one of the reactants. Okay. This one says, what's the oxidation number? So this one, so I want you to work this out and I'll tell you the answer. Oxygen is going to be -2. This is going to be a net 0. So that's -8 down here. Hydrogen is with nonmetals. So it's a +1. It has 3 of them. It's a +5. So -8 and a +5 gives you, -8 and a +3 gives you a +5. So hydrogen is +1, right? Oxygen is -2, and the phosphorus is +5. So 5 plus those 3 is 8, is going to equal to the -8 of here. So the answer is E. So try to work that one out. And this one's sodium chlorate. What is sodium chlorate? It's sodium ClO3. Sodium is +1, so it's going to be A, B, C, or D. The oxygen is going to be -2, so it makes it either A or C. So we have a -6 charge coming from the oxygen, a +1 coming from the sodium. So that means that +5 has to be your chlorine. So here's one where the chlorine doesn't follow the normal halogen rule because your oxygen and sodium do, and therefore you have to calculate the chlorine. So the answer is A. Now here's something, you might see this in ALEX. You can actually have a fraction with oxidation numbers. I want you to remember oxidation numbers are bookkeeping. This is something we use ourselves to describe a behavior. Just like with formal charge, we assign that to describe a behavior. Nature doesn't walk around going, this is my oxidation number, okay. We assign this as our bookkeeping to predict behavior. So you can, in fact, have a fraction for an oxidation number. I will not give you one of these, but you might get in ALEX. So I want to show you that you can. Potassium triiodide is Ki3, right? So potassium is a group 1, so it's always going to be +1. That means the I3 has to equal -1, and you have 3 of them, so it's going to be a -1/3 for the iodine. So just in case you get one of these in ALEX, know that yes, you can have a fraction in oxidation numbers only because it's our bookkeeping. All right, the last one, magnesium. The first two are the easiest ones. Any solid element with no charge, the oxidation number is 0, always. Any single ion, a simple ion, the oxidation number is going to be the charge on the ion. So that number 2 is D, +2. Manganese trioxide. Actually, it's manganese oxide. Where is manganese? Manganese 2 oxide. Okay, let me get my nomenclature right. That is manganese 2 oxide. So my oxygen is going to have a -2. That's not a peroxide. So that's a -6 over here. That has to be balanced by a +6 over here because this is a neutral molecule, which means I have 2 manganese to be a +6. So each manganese has to be a +3. So your answer for that one will be E. Sodium sulfate and dichromate ion, I'm going to work out on the board over here. So let's go over there. Nose itchy. So where do I go? So sodium sulfate, oxygen is -2. That is not a peroxide. Sodium is +1. It's in the group 1A column. So this is -8. This is +1, but I have 2 of them, so it's +2, right? 2 times +1, 4 times -2. So your sulfur has to be such that this equals 0. So -8 and a +2, so that's going to be +6. +6 and +2 is +8. With the -8, that will be 0. So this is going to be +6. So each individual sodium ion is a +2. I have 2 of them. I do my math at the bottom, put your oxidation numbers on the top. The other one is dichromate ion. We do not know what chromium is. The sum of this one has to be -2 because it's a polyatomic ion. Oxygen is not a peroxide, so it's still going to be -2. So 7 times 2 is a -14. So that means this has to be +14. Nope, I knew I was going to do that. This has to be +12 because it's a -2 charge. It can't be, erase that. It can't be plus 14 because it cannot equal 0. Okay, so don't make the mistake I almost made. Minus 14 and a plus 12 will give me minus 2. And that's the charge on the ion. But I have 2 chromium, so each one is plus 6. So 6 times 2 is 12, plus 12, and a minus 14 gives me a minus 2. See that? So in both of these, when we go back to the slide, both of the atoms that we calculated had a plus 6, and that would be not listed because there's no plus 6 on here. All right, so that is redox practice. Ask questions, and we'll go over it in lecture.